Business leaders are under heavy pressure to invest in AI. They want to see real business outcomes and benefits come through. 2025 was more about proof of concepts and AI assistance. As we go into 2026, we're seeing AI native apps move more and more into production and connecting to your data, and security isn't keeping up. So in this video, I want to help you get on top of it. So describe this whole new threat landscape. What kind of threats and vulnerabilities do we have? What are the types of things that you should be considering to do to secure it? And what frameworks can you use to help improve your governance, risk and compliance when it comes to AI? So I'm Claudio. I've been in the technology industry as a product manager for 26 years, riding technology trends. So I'm not an engineer, I'm not a developer talking technobabble to other techies. So I want to just talk to the everyday business leader just to help you improve your security posture. Let's get into it. The first thing to get across is how low the barriers to entry are. It is so easy to build AI native applications, to build AI agents that are connecting to your data. Okay, that's the worrying thing, connecting to your data. You've got no code, low code tools that really encourage shadow AI. You can build applications, you can build AI agents and connect them to your data. Even if you're not a developer, it's surprisingly easy to do that. If you are a developer, you're going to be coding in Python. There are all sorts of libraries that make it very, very easy to code with AI. You can connect your applications to a public LLM like ChatGPT, Claude, Gemini, etc. Or you can download an open source model and run it locally, depending on your security posture. You can download models that are just a few billion parameters that can run locally on a laptop to a few 100 billion parameters that you could run in a rack in a data center. So there's enormous flexibility, the options there, and it's very easy to get going with this. So let's ground this in some market data. Okay, what are the analysts saying? Well, Gartner says that 80% of organizations will be putting AI in their production environments in 2026. Absolutely, 2026 is proving to be a big year for AI. We've had a lot of people playing, using AI assistants, doing proof of concepts. But I think this year it's moving from playtime to prime time. According to IBM, again, most companies say trustworthy AI is essential to their business. Of course. 70% say innovation takes precedence over security. So you can see what's coming next, right? But I get this. Innovation is driving the business forward and security is keeping the lights on. But only 24% have attempted to secure their AI projects. What does that tell you? And nobody wants that, right? So let's look at a foundation model for security and start to map it to AI. You've got the CIA triad: confidentiality, integrity, and availability. So the traditional worry with AI is your data being used to train the LLM? I think that's a bit out of date now. I think LLMs are connecting to your data. That's a far bigger threat. And it may not be that your data is training an AI, but maybe it's just stored in ChatGPT chat. And that's a big no-no with security because you're putting your sensitive data in a non-controlled environment. With integrity, most people with AI have heard of hallucinations. We'll talk more about LLMs. They are a non-deterministic model, so you can't quite predict their behavior, and they will lie to you. So more on that later. The model could have been trained with poisoned data. So if you are going to train your own and build your own LLM, which I don't think is necessarily essential, but a lot of people are building their own LLMs, you've got to be careful that it's not being poisoned with data. And if you're using a different LLM, then where's the traceability and the accountability for whatever that LLM does? For availability, you may have built an agent that decides one day to delete your data. That's a big issue. How are you going to respond to that? If you've got a chatbot that's supporting customers, what are you going to do if that goes down? How are you going to resource that? So there are lots of challenges. Let's talk about some real world examples here just to whet the appetite a bit. We can learn a lot from these real examples. This first one, Samsung source code was stored in a ChatGPT conversation. So contrary to popular belief, it wasn't actually used in the training of ChatGPT, as I understand it. It was the fact that it was just stored in a chat. And that's an uncontrolled storage location for sensitive data, so that's a big no-no. But it's interesting for a couple of reasons. Samsung decided to stop employees from using ChatGPT. This was a few years ago. And I think just in the middle of 2025, they re-enabled it. So they had to go away and update their governance, risk and compliance framework for this new AI era. And the other interesting thing about this is a lot of other technology companies followed suit, including where I was working at the time. All of these AI models, chat models, were blocked for staff. A financial services company had some sort of chatbot on its website serving customers. So, a very good use case for agentic AI. But this was suffering what we call a prompt injection. We're going to hear a lot about that. And it ended up leaking sensitive information. I think it was leaking sensitive data for a period of up to about 2 weeks before it was noticed and shut down. In 2023, there was quite a famous example of someone fooling a chatbot on the Chevrolet dealership and fooled the chatbot into selling him a car for $1. Now, I don't think this was honoured, but you get the idea that these things can become a nightmare. I've heard of AI agents either suffering some sort of hallucination or some sort of prompt injection that's caused them to misbehave and accidentally delete live production data in a database. I've heard whole hard drives being wiped as well. In security, they like to have a play on words. This nightmare or natemare really comes from a tool, a workflow automation tool called N8N. So this is a no-code, low-code tool. We'll talk a bit about that a bit later in the video. But this tool could allow a remote execution attack and lead to data exfiltration. So, a very, very serious issue there. But we'll talk more about that one. Microsoft had a very interesting one with their Copilot. It was named EchoLeak. We're going to talk about this. This is a zero-click vulnerability. So you didn't need someone to just click on a file, click on an attachment, load a virus. It was just simply how a user interacted with Copilot, and it led, or it could have led to a serious security breach. Now with this one, this was found by researchers. I don't think there are recorded cases of this actually affecting anyone. Microsoft patched it. It's just a server-side, Microsoft-side patch. So there's no action on the end users. But this is a very interesting example to talk about prompt injections. And prompt injections is something that is generally not solved for in AI yet. It's very, very difficult to solve. So we'll use EchoLeak as a good example to talk about that. Microsoft Copilot is an example of RAG AI. We're going to talk about that as well. Now, this can be very penalizing. If you've got that financial services company with their agent, if that goes down, how are you going to resource serving those customers? What's the cost of churn if those customers become unhappy and leave? What's the cost of remediation? Then you've got fines. We've got this growing regulatory landscape around data protection and cyber resilience. So you've got fines, you've got personal liability for executives as well. So this can be extremely damaging. Now, for these reasons, it's important for you to take stock and get on top of this. So this means really getting on top of your governance, risk and compliance. I don't think you can take the usual approach you would take if you're developing a new application, that sort of reactive, going through governance on a case-by-case basis. I think you really do need to approach this generally and proactively because you're in a new AI-powered era. In order to get your governance, risk and compliance refreshed, I think it's really helpful to know a couple of things. The basics of the technology, how it works, how it may introduce vulnerabilities, and what sort of frameworks are there to help you. So two big technology areas we're going to talk about with AI, and in particular generative AI, is RAG AI, which has been around for a short while now. It's very common. People are building their own RAG AI, so that's going to introduce some vulnerabilities and open up your attack surface. Agentic AI is very big for 2026. We've seen a lot of proof of concepts. Some businesses are ahead of others in terms of agentic AI, but it's becoming very big in 2026. So a lot of people are going to move into AI native applications in a production environment, including AI agents. So we'll talk about that and what that means. Starting with RAG AI. So as you can see from the picture, what is RAG AI? Well, you can see the LLM is able to talk to an external database. And so we start to get a hint as to what RAG AI is. The LLM is able to connect to the outside world. But before we sort of go into what it is in any sort of detail, it's helpful to know what non-RAG AI is first. Here's an old school version of ChatGPT 3.5 from a couple of years ago. If you put in a prompt, say, for example, look at this contract, tell me what you think, you could get your contract pasted into that prompt. ChatGPT 3.5 allowed a context window of about a dozen pages. So if your contract was no more than a few pages, you'd have no problems. And it would give you a really interesting answer. Now, if you tried this, hey, ChatGPT, what was in the news this week? Then it couldn't answer it properly because it was a closed system that was trained up to a particular date. The latest version of Gemini came out just before Christmas. So you could literally drop War and Peace into this prompt. The prompt or context windows have got much bigger. So War and Peace, it's famous for being a big book. If you ramble on like I do, people might say to you, hey, I asked for a summary, not War and Peace. So hence the example. It has about 580,000 words. I think Gemini could probably take around 750,000 words. So you could paste the entire copy of War and Peace into the context window and say, maybe build me an exam paper on this. And it would go about it and do a good job. But here's the thing. It's starting to get clunky. We're having to paste huge amounts of information into that prompt. So there's going to be a better user experience. And this is where RAG AI comes from. So you don't have to paste in that whole copy of War and Peace or add that extra context to the context window. The LLM can just go and grab it from the vector database, and that improves the whole user experience. It would even, if it doesn't have it in its vector database, it can search the web and pull it in through an embedding process, and we'll talk more about that in a bit, but pulls it into an embedding process, and then it can use that information to then augment your prompt with the additional context it needs. So in the previous example, it would be to grab the copy of War and Peace and augment your prompt, which is build me an exam paper on this, and then it could add War and Peace into the prompt. So that's where the retrieval augmented generation comes from. It's retrieving the information it needs to provide the additional context, and it's augmenting the user prompt. So what the LLM actually runs on is not the user prompt, which is, could you build me an exam paper on War and Peace? It's actually acting on the augmented prompt, which is, could you build me an exam paper on War and Peace? And then here's War and Peace. Now, maybe that's not the best example because War and Peace was written over 150,000 years ago. It's in the public domain. There's a very good chance the LLM could have trained on it, but we don't know. We don't know what the LLM was trained on. But the great thing about RAG is that you get up-to-date answers. Okay, you get answers that are grounded in the real data, so it minimizes hallucinations. So very, very good step forward with AI here. And all of your favorite chat models today are RAG enabled, whether it's Copilot, ChatGPT, Claude, Gemini, etc. They're all RAG AI. At this point, it's important to introduce one of the most dangerous attacks, and that's a prompt injection. Think of this as a hypnotist attack. Now, there's probably a generation of people here that don't know that hypnosis is a real thing for humans. I grew up watching shows like Paul McKenna, maybe on holiday seen a hypnotist act, and it's for real. You watch someone whose behavior is altered through the hypnosis, and they'll do things that would break their normal behavior. They might get a trigger word, and that would cause them to behave in a weird way, something they wouldn't normally do. And I think it's a very good parallel to what a prompt injection is. You're actually hypnotizing the LLM. So the LLM has rules, it's been told how to behave, what not to do, how to go about things, and a prompt injection has just altered that behavior. And when you've got an LLM talking to your external resources, your applications, that can be extremely damaging. So we're going to look at how prompt injection can affect RAG AI. We'll use the Copilot EchoLeak as an example. So maybe this slide looks a bit technical, but let's talk about what EchoLeak is in English with an example. Let's say you were working during the day, you had some meetings, you went back to your laptop and said, Copilot, could you summarize my emails? Tell me if there's anything urgent and important I need to look at. Now, Copilot is an example of RAG AI, and what it does is it goes out, grabs your emails, pulls it through that embedding model into the vector database so that the LLM can pull it as extra context to augment that prompt. So what the LLM is actually told is, Copilot, go summarize my emails, along with all the information about the emails that you've been receiving during that morning. And if you've got some malicious code that's in an email, that gets augmented into the prompt, and it can potentially break the behavior of the LLM and lead to sensitive data exfiltration. Now, what's really interesting here is, that could be plain text within the email and see it. But it's the elaborate ways that you can hide a prompt injection that are amazing. So the first thing to talk about is this embedding model. So when data is put into the vector database, it's not a file storage or an object storage as you might be more familiar with. It's a vector database. So it's containing chunks of information about the information, if you like. And because LLMs are multimodal, they can work with video, images, sounds, URLs, text, PDFs, you name it. And with an image, it will look at the image, analyze it, and it may recognize that, hey, this is a picture of a man walking a dog in a park. The sign above his head says, welcome to the park, and here's some malicious code. Now, the embedding model will extract all of that information, and it could potentially store that malicious prompt in its vector database, and then it gets pulled in. So when the RAG AI is augmenting that prompt with the additional context it needs, it's just pulled a malicious prompt from that email and put it into the LLM and broken its behavior. Now, that's images. So you can hide text in images. Now, you may think, okay, I could look at the images and see there was a malicious code in there. But I've heard of examples where the text is so low contrast that you can hardly see it. It's not perceptible to humans, and yet it's still machine readable. There are other elaborate ways. If you think about how characters, letters of the alphabet, symbols are stored, they originally used ASCII. ASCII uses 7 bits out of the 8-bit byte. You could have 128 different characters. That wasn't enough for to represent all of the languages and symbols that are used in languages across the world today. So ASCII was expanded into what's called Unicode. Okay, and in Unicode you can have up to 4 bytes, and there are, as it happens today, there's over 150,000 standard characters defined by Unicode. So emojis, if you were to type a colon, dash, close brackets, that would be the shortcut for a smiley face. And the computer would store the information about the smiley face. It wouldn't be storing the colon, dash, and the close brackets. That's just a shortcut to get to the emoji symbol. It's because we don't have enough keys on a keyboard. We don't have 150,000 keys on a keyboard, right? So you have shortcuts that create them. But absolutely, they are represented by their own unique code. And let's just say you have a bitmap image, and you've got pixels that are represented by bytes to define how much red, green, and blue there are. If you had all those RGB values replaced by some Unicode symbols that could spell out a prompt injection, you could actually hide it in the image that way. And through the embedding model, the LLM could become confused and just see, oh, that code looks like some plain language or whatever. I'll embed that and I'll use that. And hey presto, you got another prompt injection. Maybe there's stuff hiding in the metadata, so it's not clearly in the main body of the file or the web page or whatever, but it's in some maybe commented out data or just hiding in some overhead. I even tried Morse code. I put Morse code, saved it as an image, and ChatGPT and Gemini, they decoded that like absolute ninjas. So if you had a load of dots and dashes hiding somewhere, you may not notice that, but that could contain a malicious code. I even tried it for semaphores, and these tools, ChatGPT, Gemini, are the ones I tested it on. It could absolutely see that there was a man holding flags diagonally downwards, left hand and right hand, but it hallucinated on these. It could read the images and see what it was doing, but it would just give me the wrong output. Now, I'm sure with a bit more of prompt engineering, I could get it to read semaphores quite successfully, but it's just an example of a hallucination there. Another thing about Unicode is, believe it or not, I mean, this is historically how we represent data. It's evolved over decades. There are a block of characters that are called tag characters that are actually invisible, but they represent letters of the alphabet. So you can even have invisible characters representing malicious code. So I saw an example of how these invisible tag characters were appended to a emoji. So you had the emoji, and you would have its Unicode code representing that particular emoji, and then you would have all the Unicode bytes to represent the malicious code. And when you pasted that in, all you saw was the emoji. If you copied that emoji and pasted it into somewhere else, it was pasting in all of the invisible tag characters. So you wouldn't see it because they're invisible characters. You'd have to go into some sort of Unicode program decoder and paste it in, and you'd see it. You'd see what the actual values were, and you could determine that they were invisible tag characters. So it is absolutely amazing where these prompts can actually hide, and I'm just amazed at the new and novel ways that you can hide stuff in there. So it's not good enough just to do some sort of text filtering. This embedding process is multimodal, and there are all sorts of ways you can get malicious code coming in, appearing onto that vector DB, and being used in an augmented prompt. So you've got to have controls around the LLM. The initial prompt from the user, you've got to have some sort of validation and filtering around that. The concept of an AI firewall is really important here. You've got the vector DB. You've got to have some controls there, because it's no good just filtering the prompt, because the prompt is being augmented by the vector DB. So you've got to have additional controls there. And then the output, because the LLM is non-deterministic, it's just a neural network that's had loads of information thrown at it to train it. How's it going to behave? Can you really predict an output? No. So some sort of filtering, data loss prevention, and validation on the output would be important as well. So let's summarize what we've learned about RAG AI so far, and we've introduced prompt injections as well. So let's just recap quickly. So RAG AI is good. You have outputs that are better grounded in data, and you'll reduce hallucinations as a result. But because of that additional vector database that's just expanded your attack surface, you've got to be aware that you can potentially get prompt injections sneaking through outside of the direct prompt input. So when you have a prompt injection from the user that's typed straight into the model, that's a direct prompt injection. But you can have prompt injections indirectly, fed by things like the vector database. Now, the main threat here is that with RAG AI and other uses of Gen AI, you've typically got it connected to the internet and to your personal data. And this is where the dangers lie. If you hypnotize the LLM, okay, you can potentially read sensitive data and exfiltrate it. For security, consider an AI firewall, lots of filtering, validation work. Don't just filter the user prompt. Remember, you've got an augmented prompt, you've got the vector DB here. So how is your LLM connecting out? How does it get external data? You've got to secure that as well. A really important point here is to get an AI specialist security company to penetration test it. So we call it pen testing in the security world. It's where someone's paid to act like a hacker and try to break into it. And when you've got immature technologies like this, it's really, really important to buy those services. I know it's spending money, but buy those services and get them checked out, because they are new, they're immature technologies, and they're vulnerable. We're going to move on to Agentic AI. So this is going to be big for 26. So think of AI agents as that virtual co-worker. That's a really important way to think of them, especially from a security perspective. We will call those identities. So we're going to use a use case to talk about Agentic AI, and a big one is with coding, Agentic coding. So we're going to talk about different forms of coding with the assistance of AI. We're going to talk about what Agentic coding looks like. And the big enabler with AI agents is MCP, the Model Context Protocol. So we're going to go into describing that. I think MCP is to Agentic AI as that vector database is to RAG. It's another piece of the threat landscape that you've got to be aware of. This is a piece of attack surface that you absolutely need to understand. So there are 3 levels of AI coding. So the first one, the developer is firmly in the cockpit. They're using AI as an assistant, and the concept is for autocomplete from a Copilot type tool. And some of these tools are actually called Copilots. I know you've got Microsoft Copilot that you're familiar with as an end user, but as we'll see later, we've got GitHub Copilot, which is an autocomplete tool that's AI powered that can help you code a bit faster. Then you've got vibe coding. So you're partnering with the AI here, you're riffing with it, you're iterating, you're telling it an outcome, and it goes away and writes the code. You test it, you may see something doesn't work, you say, hey, you tell the AI, this bit doesn't work, can you fix this? And you'll iterate it until you get what you want. So the human is definitely in the loop there with vibe coding, HITL. Now, vibe coding requires no coding experience from the end user. They just need experience working with AI, and good experience having a conversation with an AI to get what they need. So it's more of a prompt engineer exercise than a developer type of expertise. The last one is agentic coding. Now, when you're developing an application, actually just writing the code is just one part of the whole life cycle. So with agentic coding, we're talking about automating bits of that entire life cycle, from the whole managing of the project, gathering the requirements, designing the UI, designing the front end, designing the back end. Once you've done some coding, getting it peer reviewed, getting it tested, debugged, putting it through the pipeline if you're using DevOps so that you can get it compiled, have all of the libraries updated and packaged, ready for production, to push it into staging, and to even push it into production, and to monitor it, and then suggest improvements later. So agentic coding is more about how do you use an army of agents just to perform all of those roles to contribute to the whole software development project. So Microsoft said last year that up to about 30% of their code is AI generated, and they expect it to hit 95% by 2030. So most coding has been with copilots. Developers have been using copilots just to help them write code with a bit of efficiency. We've seen quite a bit of vibe coding, and you've got to be aware that because vibe coding requires no developer experience, it's very attractive for shadow AI. It is remarkably easy to build agents. connect them to your data, and do this from shadow AI, because you've got vibe coding tools that can help you. There's a whole heap of low code, no code solutions out there. But the human has been firmly in the loop with most of this stuff. I would say if you're vibe coding something, it could be like a small mobile app or a proof of concept in an enterprise environment. But generally, you're not using vibe coding to build enterprise grade applications. So if I've heard of kids generating apps that are absolutely powered by AI. It's not difficult to do that, and some of them are hitting the right sweet spot and making a lot of money, and good luck to them. But in an enterprise environment, an application is quite a big system. Agents can perform a whole range of jobs, as I mentioned already. That if you think about all the different jobs that need to be done across that software development lifecycle, through the project management, through the DevOps pipeline, there's a lot of different jobs: testing, debugging, scoping, and these can be all done through agents. For any part of Agentic AI, like Agentic Coding, MCP, the Model Context Protocol, is a way that allows that LLM to interface with external tools. It gives it hands and eyes into all of your systems and data. So you can connect it to your inventory database or your collaboration tools like Slack and Teams. Whatever you want to introduce as part of that workflow, you can connect it to the LLM via an MCP. And that's what enables the agent to work in a workflow, passing data between tools. So it's a very key piece of the architecture, and a very key part to be aware of in terms of your attack surface. So if you're coding, having a project, Claude Code, might be the orchestration tool you use to build your agents and have them do whatever you need them to do to support your coding. Google have anti-gravity that includes the integrated development environment as well. But Claude Code, think of it as you can write code in here, but it's your orchestration layer. So in your orchestration layer, you'd have a Claude MD file. This is like the employee handbook that tells the agents how to behave generally. This has the rules. If you think of agents like identities, you want to have good information in the Claude.md file that treats agents like employees, and it has a handbook in there that tells them what to do. Now, the agents will have their individual work instructions as well that are written probably in natural language as well. But this is the general sort of employee handbook for all of those agents. And it will contain information about the security posture, such as my private keys that I use, my credentials I use to log into these systems. Don't leak those. Don't commit them to the pipeline. Don't publish them on a public GitHub and things like that. So your security posture can be represented in there. And you pull your MCP servers into here as well, so that your agents can talk to the outside world. Then you're going to be writing your code, and a common tool for writing code might be Microsoft Visual Studio Code, VS Code. There are many alternatives here. If you're going to use something like Google Anti-Gravity, that has its own IDE as part of it. But think of this as the developer's workspace. This is where they actually write the code. And IDEs, they can spin up environments as well in the cloud to host the development code. It can spin up a development environment. And to create cloud instances, you can do that in three ways. You can go through the GUI on AWS, Google, or if it's private cloud, your VMware platform. You can go in there and go into the GUI and set up your virtual private cloud. Or if you're a developer, you might go in through the CLI, black and white text screen, and you're using Linux and text-based commands to build it. But another way is using infrastructure as code. This is where you write a configuration file in structured text called a markup language. And you write it in there, such as YAML or Terraform files if you're using a Terraform tool. And this defines how your infrastructure should be built. You can drop that config into a cloud platform and it will read it and it will go and build the virtual private cloud for you. So IDEs can build cloud environments. And I'm telling you this because you can have an agent working here with access to that file and the ability to spin up a cloud environment, okay? Just saying. When you're starting a project, you'll have an environment file, a .env file, or similar, depending on what kind of tool you're using. This is where your credentials and keys are kept. So in your development environment, as you're writing code, you're testing it, you are connecting to different applications. You are connecting to the LLM. So you could be using Claude, Anthropic's Claude here. And so your Claude instance, that LLM, you'll have to copy a key. You could paste it in here and it will allow the system, the tool to interface with Claude. This is how the agents will use the LLM to do useful work. If you're accessing some sort of database, you'd have the credentials in the env file. You don't know, nobody hard codes this into the program itself. You start to build technical debt. It's just bad practice. And then when you push that code through your pipeline and it's all packaged up and prepared, you typically use a secrets manager on the cloud platform, or you may even have a production.env file, depending on how you want to work. But yeah, it's a sensitive, very sensitive file, and there are, depending on what environment you're using, there could be other such files, similar files where credentials are stored. You are typically using some sort of Copilot to assist you with coding. These work in a small context window. They're typically looking at the code you're working in at that particular moment, and it builds up knowledge of different strings and variables. So if you need to refer to a particular part of a program over here, it can give you options as to which one you might want to do. So it can minimize human error and just make things a bit simpler for the developer. So examples of this could be GitHub Copilot or Amazon Q Developer, I think, which used to be called Code Whisperer. But you get the idea. So agents, are starting to look at things that are potentially quite sensitive. You got your library, typically a GitHub library. You could be running your own GitLabs on-prem, or you're using the cloud version of GitHub, and you would store your code in a private location or in a public shared location. So depending on if you want to give people access to your tools, if you're developing an application, you're not going to publish that publicly, but a lot of people will publish things publicly. If they've developed a new MCP server, for example, you might want to publish that and allow other people to use that and contribute to it. And the open source community starts to improve on the tools, and you benefit from that, because next time you need an MCP server or a library or something, you'll be able to pull that into your project from a public repository. So project management, code is reviewed through pull requests, and once you commit the code, you put it into the pipeline. So you can have agents working in and around this. Then you've got your constant introduction or constant integration, constant development pipeline, CI/CD. This is the essence of what DevOps is. So if it's a compiled language you're working with, so Python is interpreted, but if it's Java and C++, it would compile it. It would fix all the dependencies and libraries it needs for a production environment. It would spin up potentially an environment for it to run in, as defined by a YAML file. In fact, what the pipeline does is also defined by a YAML file. That could define all the steps in a CI/CD pipeline. Again, another sensitive area for AI agents to be sniffing around in. Testing, debugging, repairing, testing it for performance, functionality, security. And when all of that's good, it'll put it into staging and it's ready to be pushed into production. And in the DevOps way of doing things, you'd be monitoring that and you'd be iterating on that with new versions as you see things to improve. So Agentic coding is this whole life cycle of the product and all of the things that are done to it that are just outside purely just writing code. So let's talk about the vulnerabilities of that. So you've got the Claude.md file that, an agent, if they've got write access to files and stuff, they could alter that. Or if they have a prompt injection, they could ignore what's in there. They could ignore their manual, their employee manual. You've got agents that can go rogue if they suffer a prompt injection. MCP servers, because these are so easy, you're typically not writing an MCP server. You can, but you're typically just using trusted MCP servers that you'll download. So you could, if you've got agents talking to GitHub, then you need an MCP server that connects you to GitHub, and GitHub would recommend their standard MCP server for that. But let's just say you made a mistake. There are potentially malicious MCP servers that are typo squatting. So if you type in the wrong combination, like MCP space Git instead of Git space MCP, as an example, but you get it slightly wrong, maybe you end up downloading a poisoned MCP server that does a few malicious things. A more sophisticated version of that is a bait and switch attack or a rug pull. This is where an MCP server is good. It's made by a threat actor, but it's very good. Functionally, it works well. There's no security threat. It's benign. But one day it gets a version update, and that's when the malicious code kicks in. And the advantage of that for the attacker is they've built a lot of trust. They've built a user base, a community of people who are using it, and then they'll update the code, and that's where the poisoning then comes in then. So if you have a malicious MCP server, just think about what that can do. It's connecting to code, and depending on the privileges of those agents, you can delete, change, leak sensitive information and all sorts. The library, it's very easy for a developer to write in Python, which is typically the go-to language for building AI native applications. I mean, so far we're just talking about just building applications, but you could be building AI native applications in this way, right? But really we're just talking about using agentic coding to build anything at this stage. And you're going to be pulling libraries. So if you are building something that's powered by AI and AI native app, then you're going to be pulling all sorts of libraries in. You're going to be pulling libraries that will help you connect to resources, MCP servers, libraries that help you, like Llama, which helps you download your own local version of an open source LLM that you could run on-prem. There are all sorts of libraries that will help you support this, and you're pulling them down from public repositories. So you've got to be careful there about what you're doing, pulling in, have some governance around the MCP servers and the libraries that you're downloading, and make sure that you've got a bit of trust and standardization in how you go about that. The IDE, the integrated development environment, so VS Code was the example we used, but most IDEs will use an environment file containing your keys and credentials to access LLMs and different systems, resources, tools, data. These can be prone to a remote code execution attack. So there are different ways that that the credentials in an env file could be leaked. So maybe a compromised agent overwrites something in a config file that causes it to behave in a strange way. It calls an attacker's controlled URL. If I give you an example of how that works, an attacker could have a web server. Nothing dodgy about it. It's just a web server and it provides information. It just so happens it's controlled by an attacker. Now, the agent could append a credential or a secret key on top of the URL of the whatever it is, the attacker.com server / and put the key over it. And when the HTTP request or API comes in to connect to that server, because it's been overwritten with the URL of the attacker, and the agent is told to put the key over the to append the URL with it. It just looks like another page that is trying to open on that web server. Now that page doesn't exist. Okay, there isn't a page on the attacker server that has the same name as the key. So nothing happens. Okay, it just fails. It just fails to connect to that web server particular page. But it's logged on the server that someone tried to open a URL page of this, and we had to fail it. And there you go. The attacker just checks the logs and they can see the key there. I've seen examples of pinging where you could, if an agent has the ability to ping something to check if the resource is live, it could ping the URL in the same way, and the attacker can check their logs and see that someone tried to get to a particular URL there, and they'll see it in the log, and there's the credential. There's also tool chaining. Maybe there are a bunch of agents that are fairly low risk by themselves, but you chain them together. One of them has the ability to list files. Okay, then the next agent can open a file and read it. Then the next agent can take information and maybe send an email. So you chain these together, and you've got the potential ability to leak sensitive data. Another example is where the .env file gets either committed or published. In this environment, we're connecting to the GitHub library, of course, and the agent makes a mistake and publishes that env file to a public Git repository. And then they're the attacker. They can go to GitHub and see that it's been posted there. Lots of examples, different ways that sensitive data can be exfiltrated. Once they got the credentials, they're in your system, and they can execute their breach. With the CI/CD pipeline, any agents that are in amongst that, controlling that, are high-value targets because of the elevated privileges that they have. You've got what we mentioned already. What that pipeline does is defined by something like a YAML file, some sort of config file that tells it what to do. So, for example, an important step in there from a security perspective is the security testing that goes on. You've got to be careful what an agent has write privileges and can go in and edit that YAML file and tell it to bypass the security testing. It could potentially leave a backdoor in your software. So things to be aware of there. Let's talk about an example where we're using Agentic AI to automate a workflow. So N8N is an example of a workflow automation tool. So we're going to cover that sort of nightmare vulnerability that was patched not too long ago, but it's a really good example. N8N is a no-code, low-code tool. When you're working in it, it literally looks like this. You can just drop nodes into the GUI, draw lines, connect them up. If you want an LLM in the chain doing something, you can drop an LLM in there. If you want an agent in there, you can drop an agent in there, hook the LLM to it. And to use the LLM in this, to power it, you just need to copy your key, your credentials that you use for ChatGPT or whatever tool you're using, and drop it into the tool. And you've got your workflow powered by ChatGPT, Gemini, Claude, etc. So it's very easy. It massively enables shadow AI here. So you've got to have some controls as to shadow AI in your company for sure. So in this example, what was this nightmare scenario? Well, it was built around something that looked like this. This was a use case. So you've got an upload form trigger. So there was an HTTP front end, like a web page form where you could upload a file. That would, just like a RAG AI, that would go through embedding, and the agent would store it. And then the chat trigger, someone could go in, have a chat with it, and just say, "Oh, tell me about the information." So you could upload information like a RAG AI, and you'd have a chat just to query and talk about it. then like a lot of these things, you want to connect them to other systems and tools as well. So you can connect it to your internal data, applications, internal documents. So, what are the use cases for this? Well, maybe it could be medical. It's performing triage. So upload some documents about, what's wrong with you, and have a chat, and the AI agent can perform some high-level triage that directs you or prioritizes you accordingly. Maybe it's I don't know if that's a good example or not. I'm not a medical professional, but a better one, sort of closer to home to the corporate world, is maybe the recruitment process needs a bit of automation. So maybe that upload form is a CV. Maybe the chat trigger enables the recruiter to sort of query what candidates do I have, and do any of them look good? Analyze this CV and tell me how well it fits the role. Or maybe the chat trigger is for the person who uploaded their CV, just to sort of explore if they're a fit for the role, or how are they doing in the process. So you get the idea. It's a very basic tool, and it has thousands of applications in the real world. Now, where this went wrong was that the upload form was HTML sort of based. It used something called a webhook, and this is where there's an HTTP post that's being made as you upload the form. So when you upload the form, it's an HTTP post request that gets sent. What a researcher found, and again, this is a vulnerability found by a researcher, and N8N have patched it, so if you're using the latest version, you're fine on this particular vulnerability. But what the researcher found was that if they captured the HTTP, found out what it was doing, they saw what the structure of the form was, and they could emulate that and substitute some of it with their malicious code. And what their malicious code actually did is, instead of uploading a document, it was telling the agent, upload your config file. And it was, because it's using N8N, it knows there are particular files that would contain sensitive credentials, such as the environment file. So you're basically telling the AI agent, hey, could you upload the environment file? And then you could use the chat to sort of query it and ask the agent, oh, give me your, give me the contents from the environment file. Tell me what your credentials are, and it would play it back to you. So absolute nightmare scenario. So when vulnerabilities are published, when they're known, they go onto a vulnerability database and they're given a score. This one was a 10 out of 10, because you're giving away the credentials to log into this N8N instance. Go in there and you could create your own nodes, like an execution, a code execution node in there, and run your threat. And of course, for these agents to be of any use, they need to connect to different systems and applications and data. And so you've immediately got all of that access too. So, if you've got all the documents that you've stored also connected, then, what a nightmare scenario you've got there. So the blast radius is potentially massive, depending on how well this is connected into your systems. So yeah, as I said, this was patched. If you're using the latest version of N8N, you're covered from this. But prompt injections are not solved yet. This particular vulnerability was patched, but prompt injections are still here to stay for a while. Right, this is where it's probably good to sort of talk about hallucinations. So think of hallucinations as lying. Now, the LLM doesn't have, a strong sense of morality. It doesn't have human emotions. It only has what it's been instructed to do. And if the LLM is being instructed to be helpful and to work within some safety guidelines, great. But and we've seen a prompt injection can alter that behavior. But sometimes the LLM, when it's trying to be helpful, will just tell you something that's just factually incorrect. If you want to see a visual representation of this, use an image generation tool. So look at it, and particularly from a couple of years ago when they weren't as good, you'll see the human form with hands with extra fingers growing out of weird places. So that was a visual representation of hallucinations. I want to give you another example here, that if you've got your LLM powering an agent that's communicating with live data, it's not very good at counting that kind of stuff either. So we've seen it hallucinate on that. An example is, a friend of mine was, downloaded ChatGPT's, one of ChatGPT's open source models. I think it was the 120B, had 120 billion parameters. It could have been the 20B with the 20 billion parameters. But, something half decent that could perform some really powerful stuff. Probably needed to run it in a few servers and have a few GPUs in there powering something like that. But what he wanted to do is to attach an LLM to the network infantry to really discover what's happening in the network, and use human natural language processing to query the network. And it was very good at it produced really interesting results. Very good at working with it. He used a llama to pull that LLM and run it on-prem, did a bit of Python coding, pulled in MCP servers to connect to the different inventory tools that he was using. All very simple, but it was hallucinating. So, if you asked it how many interfaces conform to this condition, and if it was expecting the number to be in and around 1,000, it was getting the answer wrong quite a lot. And these were hallucinations. And so what you need to do in that scenario is use a tool behind MCP to do that. So you really reduce the LLM to do reasoning, natural language processing, and things like that. But if you're working with live data in a system, it's probably better to use an external tool to do that. So you find this with trial and error. You discover what LLMs can do, what they can't do, and sometimes they can be surprisingly stupid in certain respects, that you really didn't expect it, because you're able to have a really powerful conversation with an LLM and you're tricked into thinking it's really, really smart, but then it goes and does something dumb. So yeah, just be aware of that and know hallucinations exist. You've actually got to test your stuff for hallucinations. I have heard of a hallucination causing the wrong piece of instruction to be pulled up, which led to the accidental deletion of an entire hard drive. So results can be potentially catastrophic if the lie is destructive. So this isn't going to be an exhaustive way of how do you secure AI, but there's a few good pointers here. The first we'll start with, you've got to follow good security practice. So zero trust, least privilege access for agents is really important. You've got to treat agents like employees, so you've got to assign them identity. So a massive part of security and with zero trust and least privilege is identity access management, IAM. And they've got to be treated like employees and given a role with the least amount of access that they need. If they don't need write access, don't give it to them. And if they don't need access at night, then take it away at night. If you're done with the project, or done with that agent, then tear it down. So privileges should be least privilege, but they should also be ephemeral. So only exist while the agent actually needs it. You've got to assume attacks can be successful. We're dealing with fairly immature technologies, just like with SQL injections with websites when that .com bubble exploded. It took a while for SQL injections to reduce to the point where you can comfortably run a web server these days, and you've got all the security checks in there. But prompt injections that work in a similar way, they are here for a while. Okay, so you've got to have multi-layered security, because it's very easy for new vulnerabilities to be discovered. As I said, penetration testing is also very important. But you've got to assume that an attack will be successful at some point, and therefore being able to detect and respond to threats is really important. So when we talk about different frameworks, we can talk about how you can potentially figure out if you've already been breached, but having tools that help with detection and response is really, really important. For the AI specifics, human in the loop for coding, absolutely. You've got to check code, be aware of malicious code in stupid places like hidden off to the far right. So if you're reviewing some code, we've heard of scrolling far to the right, and you'll see malicious code hiding in there. And because people tend not to word wrap their code when they're looking at it in the screen, they would have to scroll all the way across. So you don't want to sort of miss silly things like that. You've got to treat agents as insider threats, absolutely. Keep them running in containers or micro VMs. So it's not just enough to give them the least privilege access they need, but to also enforce that by running them in a container or a micro VM. So micro VMs, they're like little, if you're working in your laptop, for example, let's talk about what non-containers and non-VMs are for a second. If you're working in your laptop and you're doing everything in your laptop in your normal day-to-day work, you're working in bare metal. So you've got one operating system and everything you're doing is living in that environment. But when you're doing this stuff, when you're working with AI and when you're working with agents, you've got to virtualize them. So you've got to have them running in almost separate operating systems, so they don't share the same environment with everything else. And the way to separate their environments is through containers, which is like a light operating system, if you like. You only get it's sharing your operating system, but all the dependencies and libraries it needs are within that container. At micro VMs, you get a bit more of the operating system that's there dedicated for that little micro environment. So never run in bare metal. So especially when running code for testing and things like that. So you've got to keep separation in there. Have some governance around MCP servers. You've got to have them approved because it's so easy just to download them. They'll connect to absolutely anything. So make sure you've got governance around that. And you've got to test them. You've got to make sure that a new code, you haven't had a bait and switch or rug pull attack on that. Suddenly a good MCP gets updated to a bad one. Absolutely have instructions to the LLMs to enforce guardrails. Context isolation is very important. So it means that prompts can't be affected by other things that they found in other resources. So it's like telling the agent, don't listen to the bad guys, only obey these instructions. Now, that's all important to do. Information in the Claude MD file and getting the security posture clear by the agents is very important. But remember, multi-layer security, a prompt injection can potentially break that behavior. Auditing your files. So if you're using agentic coding, then have agents that are checking what the other agents are doing. Have agents that are checking that config files, that environment file, the YAML files and config files, etc. That they're alerting you if any of them are being changed. You've got to try and mitigate for possible hallucinations, test it properly, and make sure that you're not having hallucinations become a factor in possible damage. And you've got sensitive keys there, so be careful what the agents have access to. Be careful that you're not going to leak those keys. And in one of the many ways I told you earlier that they could be leaked. Now, useful frameworks. So, that wasn't an extensive, instruction on how to secure it. You've got to refer to frameworks. These frameworks will help you drive your governance, and they'll provide you with a wider variety of resources to help you secure this stuff. America has NIST, and they're all over security. They're a great organization, and Cybersecurity Framework 2.0 is a foundation model that's used extensively in cybersecurity. We also use their zero trust framework to help customers go on a zero trust journey. That's really, really good. So it's no surprise that they're going to be all over AI. So they've got their risk management framework. They've defined 7 characteristics of what trustworthy AI is, and it helps. It's a voluntary standard, and it helps give you some guidance as to how you can go about AI. So this is a good one for technical leadership, I would say. This one is for your SOC, for your analysts, for your security engineers, anyone that's going to be trying to prevent a threat or do some sort of security incident management. MITRE Atlas is essential for that. So if you any security professional is going to be familiar with the MITRE ATT&CK framework. This is the MITRE Atlas framework. Because AI has brought its own threat landscape, MITRE, the organization that developed this, rather than adapting or updating their ATT&CK framework, which is generic across enterprise cybersecurity, they created a whole new model just dedicated to AI. It's its whole new threat landscape here. So MITRE Atlas is from the MITRE organization. It's a newer version or an alternative version to the MITRE ATT&CK framework. It's the same sort of thing, but it's geared towards AI. So what is it? It deals with the TTPs, which are the tactics, techniques, and procedures of a threat. So if you think about a threat, a bad actor performing something on your network that leads to some sort of catastrophe like a DDoS attack or sensitive data exfiltration, or it locks you out of your data, there's a whole life cycle that relates to that threat. From right at the beginning, if you think about a burglar, what are they going to do? They're going to, as the Americans say, they're going to case the joint. They're going to go around, do a drive-by, look at where your vulnerabilities are. Oh, look, I see doors, I see windows. They'll have a look at when are they in, when are they out? Is there a security light there? What sort of cameras are? So, and it's the same for the life cycle of a threat. The first stage is that reconnaissance. So reconnaissance is the tactic, and so underneath the tactic of reconnaissance, they've listed 8 techniques. And so the first one is active scanning as an example. So as you go through this, as you go through the life cycle of this, you get to the end, which is what's the outcome? Oh, well, they've stolen the cash and jewelry from your house and have run out the back door and left with it and sold it. So everything that happens in there, but how they break in, what tools they use to break in, how they get around the house, where they look for it, how they prioritize, how do they find the money, how do they carry the money out, how do they get out. All of that leads to a procedure. So you're going through the process of all of these tactics and techniques, and hence you've got the phrase TTPs. So when a new threat comes out, when someone's being attacked or a new vulnerability has been figured out, the TTPs are mapped out in the MITRE framework, and for AI, it's the Atlas framework. And this gives analysts a really powerful tool because they can click on this, they can understand it, they can just think, oh, okay, here's a new threat here. This one could apply to us because we have those same systems and we could be vulnerable. Oh, it's a score of 10. Okay, well, let's go through the TTPs of that and be proactive because we're worried about it and we might actually be breached already. Let's go and check that. And they'll do something that's called threat hunting. And with threat hunting, they'll go through that entire life cycle. They'll look at all of the TTPs and they'll think, okay, these are the indicators of compromise. So has someone been casing the joint at the beginning? Is there any evidence on my front door that they've tried to break in? Is there anything on the windows? Has my camera been disabled? Are there muddy footprints in the hallway, etc.? And as you go through that, you're looking for indicators of compromise. So these frameworks can help you design your indicators of compromise and go threat hunting to see, have you actually been affected by this? So really, really useful framework. And my advice for the business leader is, you may not have got fully off the ground with AI yet, but are your analysts and engineers, are they trained in AI? Do they understand how an indirect prompt injection can come from? Are they even aware of the MITRE Atlas framework? Have they been trained in that? So everything that I've explained in this video so far, your security analysts and security engineers already need to be aware of if you're doing anything in AI. And all of your security professionals absolutely need to be aware of the MITRE Atlas framework. OWASP, the Open Worldwide Application Security Project. Now, this is more for your developers, the people writing these applications. And if you're building AI native applications and getting into agentic AI, then you certainly need to be aware of this, and your developers need to be up to date on the guidance from OWASP. They're famous for creating their top 10, their top 10 threats or their top 10 recommendations to deal with stuff. And it's no surprise that because AI is massive at the moment, they've got their top 10 for agentic applications in 2026. So developers, give them a day out learning about this kind of stuff. Get them on a training course and just make sure that they're aware of the threats. It will cover some of the types of things I've talked about today, but hopefully it will help them, give them some solid guidance as how they can better secure their applications and their environments. The International Standards Organization has aimed the artificial intelligence management systems. Again, it's another, like the NIST one, it's a voluntary standard, and it's just a way you can have a plan, do, check, act cycle for continuous improvement, to increase your security posture in relation to AI. It's got a lot of useful information in there. So I think this is, again, more for the business leader, this one. So I think, have a look at that and just see if this is something that can help you with how you go about your frameworks and compliance and your risk management. So how do we see this playing out for this year and into the next year? Well, AI native apps are going into production in 2026. People are moving from proof of concepts, experimentation, assisted AI into full AI native applications. The attack surface is going to expand. Security isn't quite keeping up, but it needs to. So are we going to see a lot of train wrecks ahead? Well, hopefully not. We've got a lot of regulations that have kicked in. GDPR is protecting personal data, and you've got a whole heap of cyber resilience regulations that have come in. NIS2, DORA, Cybersecurity Act, Telecom Security Act, and you've got AI regulations coming in the future as well. And with these regulations, you've got fines, personal liability, and reputation at stake. You've got to report significant IT incidents to the regulator or the CSIRT. So I think these are the things that are going to help to stop organizations just sleepwalking into expanding their attack surface blindly. Now, we talked about AI expanding the attack surface. Hopefully we can see from this video that it's a whole new threat landscape. But I think we've got to remember the CISO has already been dealing with an expanding attack surface over the last decade. We've had applications move into the cloud, into software as a service. So all the applications are everywhere now. And then particularly with COVID, we've had people working from home. So with applications everywhere, people everywhere, who's inside that corporate network? It's a challenge. And I think CISOs are struggling with that because they're not the most heavily resourced department in a company. They're there to try and keep the lights on. As much as they'd love to move towards zero trust, they're struggling to make progress in that area. And AI is just a big extra worry on top of that. Now, companies, they still need to innovate, they still need to push forward, but leaders, they're not becoming AI experts overnight. They're going to need the help of consultancy firms. And I think someone's going to need to orchestrate that as we progress. So I do see a new role in the organization, and that's something like a chief AI officer. The chief AI officer is going to be driven hard to invest in AI and to deliver those business outcomes, those savings, that competitive edge. Okay, they're really going to be under pressure to innovate. They're going to live by mantras like move fast and break things, fail fast and fail often, or perfection is the enemy of progress. And this is at complete odds to the CISO. The CISO live by mantras like fail to plan, plan to fail. So it's going to be interesting to see how these two roles conflict and play nicely together. But that's the point of this video. It's for the rest of us to appreciate that this is a whole new threat landscape, and let's not sleepwalk into a disaster. And hopefully content like this can just raise awareness about what businesses need to do, respect the possible security issues associated with AI, and go about it responsibly. So I hope you found this video useful, and thanks for watching.